Welcome back, everybody, to INE's CCIE Security Version 4 Advanced Technologies class. In our next section, we're going to start our discussion of the ASA Firewall. And in this first section, we're going to talk about a basic overview of what are the different features of ASA and what is the scope that we're going to be discussing, not only from a firewall filtering point of view, but also its other features like VPN termination, IPS, etc. In this section, we'll focus on how the stateful filtering actually works in the ASA. What are the differences between single context mode and multi-context mode? What are the differences between the routed firewall and the transparent firewall? And then what are some of the VPN termination features that the box supports? Now, one of the important points that has changed in the new version 4 blueprint with security is that there's now multiple platforms and multiple versions that are tested on in the ASA. So multiple hardware boxes and multiple software boxes for ASA. We have the regular ASA that is going to be running either version 8.2 or 8.4. And then we have the newer ASA X that is going to be running version 8.6. Now, there's a couple different reasons why they're using multiple releases in the new blueprint, and mainly it has to do with feature support and also the syntax for this feature, these feature supports. Now, we're not going to get into all of the details now. As we get to these individual features, we're going to be comparing and contrasting what are the differences between 8.2, 8.4, and 8.6 for the individual features. But just as a quick example, we'll see that there's a major change in the network address translation syntax between 8.2 and 8.4, and also the way that access lists interface with the NAT feature and how the global ACL feature can be used to filter in all directions at the same time. Now, our particular technical discussion is going to be relevant to all of these versions. The vast majority of features have stayed the same between the releases, between 8.2, 4, and 6. Additionally, 8.4 and 8.6 are effectively equivalent. The main difference between them, though, is that 8.4 is going to be for the regular ASAs, and then 8.6 is going to be for the ASA X, which is essentially just a newer hardware revision. Now, what we are not going to be talking about is the newest 9 code, which adds further changes beyond this that are outside of our scope, specifically for CCIE Security version 4. And one of the main changes that version 9 adds that has been lacking up to this point is that now you can do VPN termination when you are running in multi-context mode. And there's different variations of how you can mix multi-context mode. It basically is trying to uniform all features so that you can run them all at the same time. So in our particular code, in the 8.2, 4, and 6, when we look at running in single versus multi-context mode, transparent versus routed firewall, we'll see that depending on the individual features that we enable on the ASA, it's also going to be removing other features that we can no longer configure, like the lack of ability to terminate IPsec VPNs or SSL VPNs when we're running in multi-context mode or when we are running in transparent mode. But first and foremost, we know that the ASA is a firewall. Now, up to this point, we already discussed how the basics of stateful firewalls work when we were looking at iOS and talking about the difference between stateless access lists that are just saying permit port 80 out and permit returning port 80 in without doing any type of inspection to see what's actually going on inside the layer 4 header and beyond inside the actual payload. But in the case of the ASA, it is a stateful firewall, which means that it's also going to support application-aware inspections. So just like in iOS, when we looked at the content-based access control and the zone-based policy firewall features, we saw that the differences between those and the reflexive access list is that the stateful firewall with application inspection is able to deal with any type of non-standard TCP or UDP application. So for example, if we're doing a SIP phone call or an H323 phone call, IP phone call through the firewall, there are specific application inspections for those individual protocol signatures. So the firewalls are going to be able to inspect the traffic as it goes out and then allow the traffic to dynamically return back in. Now, beyond regular firewall filtering, it also supports VPN termination. We're going to spend a lot of time talking about this later when we get through iOS VPNs and ASA VPNs, as well as remote access versions. And in the current versions that we're dealing with, this is going to be both IKE version 1 and IKE version 2 IPsec, which is what we call the Flex VPN for IKE v2 in iOS, and also SSL VPN. So this means the clientless web VPN, where you can connect to the ASA with your web browser and then access resources behind it without having to install VPN client software, and then also the AnyConnect SSL VPN client, where we have the actual software client installed. We treat it similar to an IPsec Easy VPN, but of course in the control plane and the data plane, there's going to be a difference between the IPsec VPNs and the SSL VPNs. But ultimately, functionality-wise, it's the same thing, that we're trying to tunnel our traffic inside an encrypted tunnel to the ASA in order to access resources that are on the inside. We'll also look at using the ASA as an intrusion prevention system, where on the regular ASAs, the 5500s, this is with an add-in module called the AIP SSM, for the application inspection and prevention. So AIP is basically talking about the IPS. The SSM is just the shortcut for the module name there. But when we also look at the ASA X, this is going to be built in as a software module. So specifically in our case, we have two different platforms. We have the ASA 5510, which is the regular version, the older hardware, and then we have the 5515X, which is going to be running the newer code 8.6, and then is going to support some of these more advanced hardware features, like the IPS in this case. Also has support for content filtering, where with the regular 5500s, this is going to be with the CSC SSM, and then in the 5500Xs, what is now what we call the ASA CX. Now the ASA CX is going to be a feature of version 9, however, so we're not going to be dealing with this within our scope of the 8.6 code. But basically ASA CX is going to be a built-in software module for doing more deep packet inspection. The AVC, which is like doing NBAR, but similar to how we'll see that the like the Ironport web proxy does it, where it's doing more of a deep packet inspection. Now for today's discussions, we're mainly going to focus on the firewall filtering and some of the hardware applications or some of the hardware features of the ASA. We'll talk about how failover works in routed mode. Then as we continue further, we'll talk about running in multiple context mode, in transparent mode with single and multiple contexts, and also how failover works with those before we get into our VPN discussion, and then likewise IPS and beyond. So we'll see that ASA is basically going to be broken up into multiple topic categories as we're going through this class. So the ASA section on its own is mainly going to be focusing on firewalling. Then when we get into VPN, we'll talk about VPNs on iOS and ASA. When we get into IPS, we'll look at IPS on the actual IPS sensor and on the ASA, and then likewise content filtering when we get to the Ironport web proxy. Now, one of the most basic applications, or one of the most basic settings of the ASA that we need to be aware of, regardless of what type of mode that we are running in, whether we're running in single context mode, multiple context mode, routed firewall, or transparent firewall, is what the ASA has as a notion of these security levels. Now, we could think of these as an equivalent to the zones that we talked about in iOS and the zone-based policy firewall. It's going to determine what should be the flow of traffic, which are the more secure segments of the network versus the less secure segments. It's essentially going to be what is the level of trust of that particular link. So this is going to be a software configuration, which is the security dash level, and it's going to be a number in the range of 0 to 100, where 100 is going to be considered the most trusted interface. This is going to be assigned to the inside interface by default, and 0 is going to be the least trusted or the most untrusted interface, which is going to be assigned to all other ones by default. Now, a key point to note here, and we'll see this when we get to the actual implementation, is that the ASA is only going to pass traffic if we define both the names, or both the interface's name and the interface's security level. Now we'll see that there's some shortcuts to doing this, like when we define the name as inside, this is also going to define the security level as 100, and when we define the name as outside, it's also going to define the security level as 0, as the most untrusted or the least trusted interface. But a key point being here that we need both of them. So from a troubleshooting point of view, within the scope of the CCIE lab exam, they could theoretically go in there and remove the name if or remove the security level, and then the ASA is not going to pass any traffic. But this is going to be independent of the mode, so whether we're running in routed mode or transparent mode, and whether we're running in single context or multiple context mode. So all of the interfaces need to have a name, all of the interfaces need to have a security level. Now the basic logic of this is going to be similar to the inside zone, outside zone that we were talking about in the iOS zone-based policy firewall, where the traffic from the higher security level, which is the trusted interface, is going to leave out the interface with the lower security level, and we are going to allow that traffic. So for example, traffic going from the inside network to the outside network, that's going to be allowed. Now the return traffic coming from the lower to the higher security level, this is going to be permitted if there is state information in the stateful firewall, in the state table or connection table. Otherwise, it's going to be denied by default. So when traffic tries to go from the outside interface to the inside interface, if the traffic is not a return flow, like the response to a web browsing request, then the traffic is going to be dropped. So higher to lower is allowed, but lower to higher is not. Now, traffic between interfaces that have the same security level is going to be denied by default. So this is a different behavior from the zone-based policy firewall in iOS, where when we have two interfaces that are in the same zone, we are going to permit that traffic automatically. In the case of the ASA, we are not going to allow this. So if we have two different outside interfaces, outside 1 and outside 2, that both have security level 0, the ASA is not going to route the traffic between those interfaces. Now we'll see that we can do some exceptions. So there is a command in order to permit traffic to go between interfaces that have the same security level, which specifically is the same security traffic permit inter-interface command, which should not be confused with the same security permit intra-interface. We'll talk about this later when we get to VPNs. This is for a design that is known as hairpinning, where typically your VPN traffic is going to come in on the outside interface and then leave back on the outside interface. So if you're doing like split tunneling back out to the internet over the ASA. So we'll talk about that one later when we get to VPNs, but main point being here is that by default, traffic between interfaces of the same security is going to be denied by default. Now, of course, we can make exceptions to this. We can bypass the security levels by configuring either inbound access lists on the interfaces, or in the newer versions, we can configure the global ACL that is going to apply inbound to all interfaces at the same time. So again, if we look at this from a visual point of view, and let's say that we have the ASA here that has 3 interfaces. We'll say that the link on the bottom, this is going to be our inside. The link on the right to router 2, this is going to be our outside. And then let's say that the link to router 1 is a third interface to the DMZ. So this is like where we have our, let's say that we have our public web browser, or our public web servers here behind router 1. So if we were to say that these interfaces had security levels 100 for the inside, 0 for the outside, and somewhere in the middle, let's say 50 for the DMZ, this means that traffic would be able to go from the inside to the outside, because we're going from higher to lower. Then when traffic comes back in and tries to return, the ASA is going to check the inspection table before it decides whether the traffic is going to be routed between these two interfaces. Now, this also means that traffic would be able to go from the DMZ to the outside and then return. traffic would be able to go from the inside to the DMZ and return. But by default, traffic flows would be denied from coming outside to DMZ or outside in, or going from DMZ to the inside. So again, anytime we're coming from an interface that has a lower security level and then trying to go to a higher security level, that's going to be dropped by default. Now we'll see that this does get kind of confusing when we compare it to the zone-based policy firewall, because there's not a way that we can apply a specific inspection rule as traffic goes between a pair of interfaces. So it's always going to be using this security level to define, is the traffic allowed to return based on the inspection. So anytime we have 3 or more security levels on different interfaces, then we have to be very careful as to what particular traffic flows do we want to allow to leave the network and then ultimately to return. Now, from an inspection point of view, the ASA is going to be inspecting our TCP and UDP traffic by default, and this cannot be disabled. So all the web browsing traffic, all of our connectionless traffic, that's going to be inspected by the ASA inspection engine as we go from the inside to the outside by default. And this is going to be from the higher security levels to the lower security levels. So we are not going to inspect traffic as it comes from the outside to the inside by default, because that is going to be dropped based on the security level. So for example, if we had traffic that was coming from the inside to the outside and it was a web browsing session, so watch port 80 as it comes from a client on the inside to a server on the outside, we're going to create an entry in the state table. And then when the flow tries to return, we are going to check the state table before we go to the ACL implicit deny on the interface. Okay, or even if we have an ACL explicit deny, we'll see. So always check the state table first, similar to how the CBAC feature set or the zone-based policy firewall works in the iOS. This is always going to be processed first before we look at the access list, because those are going to be the return flows that we're trying to allow back in from clients that initiated traffic on the inside to out, and then it is returning. Okay, so we're going to also track any traffic that tries to come back in the return flow. So we create the state as the traffic is leaving. So if we look back at our diagram here, let's say that we have the test PC here that's trying to get to this web server on the DMZ. So we're going from high to low. The traffic goes out. The ASA is saying in the state table, I had traffic from the PCA and it's going to whatever the web server is. So then when the return flow comes back in, we're going to check this state table to see, is the web server allowed to return the traffic back to the PC? And it's going to look at that based on the specific connection data and based on the specific application. So we'll see that it does more than just a basic layer 3 or layer 4 inspection, depending on what the particular application is. So if that entry is in the state table, we're going to permit it. So in this case, the return web flow from the server back to the client. But if there's no entry, we are going to deny it. So for example, if someone tries to do a port scan on the network from the outside, the ASA is going to silently drop that as it comes in on the outside interface, because it's trying to go from a low security level to a high security level. So again, high to low is allowed in the return, but not low to high. If I have traffic from a trusted interface to an untrusted interface, do I have to have some permit or deny ACL set, but the packet does not match any of the ACL configured? Will the traffic be allowed? So I think the question is saying, if let's say we have an ACL in on the outside interface that simply says deny. So will the traffic be allowed to come from the inside and go out and then return? Yes, it will if it creates the state. So we'll look at that. It's kind of an order of operations issue that we check the state table first before we go to any of the accessless interface. There's another question. What about global interfaces, I see more and more implementations where they define global rules. I'm assuming this is referring to the global ACL. We will talk about this when we look at the newer code, either the 8.4 on the regular ASAs or the 8.6 on the ASA X, and then we'll look at what the difference in the behavior is for the ACLs there. Then another question: if you have an ACL on the inside, does that override the security level? If you do a deny, yes, it would. So if there's specific flows that you don't want to leave the network, so for example, let's say you don't want people to be browsing on port 8080 on TCP. You could configure an inbound in ACL that says deny 8080 and then permit. So that would be processed before the inspection works. So we'll look at the order of operations. It can get kind of confusing exactly how it's processed. The easiest way to look at this, we'll see, is that there's a feature known as Packet Tracer in the ASA that basically goes through all the inspections and any of the rules that you have configured and tells you exactly what is the order that the ASA is processing this in, and it tells you what's the final result. So was the flow permitted or denied? And if it was denied, it tells you specifically why it was denied. Was it because of an ACL? Was it because of the NAT process? Was it because of inspection? Something like that. So it's basically like a synthetic packet generation that we can use to debug the traffic flow as if it was going through the ASA. So very useful troubleshooting tool we'll see there. Okay, so how does the ASA actually do the inspection then? It uses what is called the Modular Policy Framework, or the MPF. Now the MPF is going to be very similar to the MQC in iOS, and also that C3PL, which is the common policy language, whatever that acronym is for iOS. It basically means that there's going to be class maps to match the traffic. There's going to be policy maps to say what are we going to do with the traffic, and then we apply it as a service policy. So the logic that we looked at with the zone-based policy firewall, it's going to carry over fairly similarly to how this works in the ASA. So ultimately, the modular policy framework controls what type of traffic is going to be inspected. So this is the class maps that are matching our basic layer 3 or layer 4 traffic. Like, is it TCP going to this particular web server? I can apply a different inspection policy. Or is it ICMP echoes leaving the network? I could say to allow the echo replies back inbound. This is also where we're going to do our application aware inspection. Now, we didn't yet look at this with iOS with doing layer 7 inspection with the zone-based policy firewall. We'll look at how the ASA deals with this and then circle back around to the zone-based policy firewall because they're going to be very similar to this. But the key is that there's going to be different inspection engines depending on what particular type of application that we're doing. So for example, if we're inspecting web traffic, there's different commands that you use in HTTP, like a post or a get, versus commands that you would use in SMTP, like hello or recipient to, etc. So the main point being that the ASA understands at the application level what is the communication supposed to look like, and then you could say, I want to allow these specific portions, like allow people to browse the web, but don't allow them to upload files. So if I see HTTP post, I could reset that connection or drop the connection. Because for that individual application, we have a separate inspection engine. Okay, it also controls how is the traffic being inspected. So we could say for this particular web server, I want to limit how many half-open connections that I have. This would be similar to what we talked about in iOS with the TCP intercept feature, and then also how that carries over to the content-based access control and the zone-based policy firewall. So if we're trying to do denial of service prevention, that's how we do it in the ASA, is to use the modular policy framework to say this particular segment or this particular server has these type of application inspection properties, and this is what we're going to do with the traffic once we go above that limit. Or maybe we have separate QoS that's applied to that particular type of class. Okay, it also defines what is the direction of the inspection. So are we inspecting the traffic as it is leaving from the inside to outside? Is it from inside to the DMZ? We'll see that by default the ASA has a global policy that is doing inspection in all directions. But the inspection is still going to first be subject to the security level. So traffic outside to inside is not going to be inspected by default because normally that is dropped. So this means, for example, if we have a web server on the inside that we're trying to allow people from the internet to come in and browse to, we would first need to configure an access list exception to say that traffic is exempted essentially from the security level. Then it would be forwarded to the inspection engine. So with the global policy, which is the default MPF, it's going to be in all directions, assuming that we have the access list to allow the traffic to hit the inspection engine. Okay, so we'll see once we get to the command line example specifically how we do this, and then what are the features and functionalities of how the inspection policies work. Okay, the other big feature that we have in the ASA is what we define as the contexts. Now, ASA supports two different types of context modes. What we call single context mode, which is the default, and multiple context mode, which essentially is virtualization of the firewall. So this would be similar to how we have VRFs in iOS, or what Nexus calls VDCs, or what iOS XR calls secure domain routers. We're basically taking one physical box and then we're splitting it up into multiple virtual boxes. Now behind the scenes, it's still controlled by the single control plane. So there's going to be hard limits to the platform, like how many inspections can I do, how many connections can I have, how many access list entries can I have, and then those are going to be shared across the multiple contexts. Now we'll see, of course, that there are limitations to how the context works. In the single context mode, this is going to be the default, where basically we have just one firewall where everybody is sharing the same interfaces, everybody is sharing the same security policies. So you can think of this like a router with just global routing going on without any VRFs configured. Now when we look at multiple context mode, this is where we're going to have separate configurations, separate policies on a per virtual firewall basis. Now it also says interfaces here. We'll see that these interfaces could be physical interfaces or they could be logical interfaces. So you can share physical interfaces between the multiple contexts, but from a management point of view, they're going to be treated as separate logical entities. So if context 1 and context 2 are sharing the same outside interface, we can still have different policies that are used to inspect traffic coming from inside to outside for context 1 versus inside to outside for context 2. So from a data plane point of view, they essentially look like physical boxes, but from the control plane point of view behind the scenes, it's still sharing the same CPU, the same memory, the same physical resources of the box, but logically we are separating it, usually for either managed services or some type of policy separation. Like if we're doing shared hosting, you could use the larger platforms, let's say like the ASA 5585, and then say on a per customer basis, I'm going to give you an individual context. So then you can control your own firewall policy without having to get me involved, but at the same time, I don't have to buy one physical box for each individual customer that I want to offer them the firewall services for. Now beyond the context, the ASA can also run in two different firewall modes, where these modes are going to be the routed firewall and the transparent firewall. Now we already talked about this in the case of iOS, where we know that a router is doing routing by default, where normally its interfaces are in separate IP subnets, and then we're using the layer 3 routing table in order to move traffic between these two links. The same is going to be true of the ASA. So it runs as a routed firewall by default, where the interfaces are in separate IP version 4 and IP version 6 subnets. We're also going to be in separate VLANs, so different broadcast domains, and then traffic is going to be routed between these interfaces. So of course this then implies that the ASA has to do routing. So either we need static routing configured or some sort of dynamic routing protocol like OSPF or EHRP in order to make the decision of how we're going to move the traffic between the links. But ASA also supports transparent firewall, which means that the interfaces can be in the same subnet, but they would be in different VLANs. So this type of design is generally less invasive to the rest of the network design because we don't have to renumber the network or we don't have to change the routing protocol design. We could put the transparent firewall behind our edge routers or in front of our web servers, and we're really not going to have to reconfigure anything other than the layer 2 VLANs that are configured on the switches. Now, the disadvantage of doing this is that when we turn the transparent firewall on, in the 8.x versions that we're using of the ASA code, there's a lot of features that you lose. Okay, the main one being the VPN termination. So we cannot do transparent firewall and be an IPsec VPN endpoint or an SSL VPN endpoint at the same time. But just like in iOS with the transparent firewall, traffic is then going to be bridged between the interfaces. So we'll have a MAC address table that we're tracking traffic as it comes in from the inside, going to the outside, and vice versa. And depending on the version that we're running, if we're looking at before 8.4, like in our particular case, we'll look at this on 8.2, you can only do one bridge group and 4 interfaces per bridge group. So you can only do one bridge group between 2 interfaces, and then in the newer versions, you can do multiple bridge groups with up to 4 interfaces per group. So this is then one of the big changes we'll look at in the newer code. When we're looking at 8.4.8.6, there's a change in the behavior of the transparent firewall and its design versus the 8.2 and before versions. So we'll look at both of the variations of that. Okay, there's a couple questions here. What is recommended in the data center from a design point of view? Do we want to do routed or transparent, and how does that affect multicasting? Okay, very good question there about the either multicast routing or multicast bridging, and we're going to look at that in both cases. So we'll have a separate section once we do the routed firewall, the transparent firewall, and multiple contexts in both variations. We'll then look at multicast. How does the routed firewall affect that, and how does the transparent firewall affect that? There is a difference in the design when we're dealing with multicast. Now, versus for saying routed versus transparent firewall, which is a better or which is a more appropriate design, it really depends on your individual application that you're trying to solve with it. Okay, if you don't need the firewall to do VPN termination, then I would say go with transparent. Because transparent in general is less intrusive to the design. It means less IP subnets, it means less layer 3 routing devices, and it makes the policy if we're just doing filtering a little bit simpler. But if you're also using it as a VPN termination endpoint, then that's going to be a problem depending on the particular code that you're running. So traditionally that was the main deciding point. Do you want to do just firewalling, or do you want to also do VPN? That determines, are you going to do routed, or are you going to do transparent? Okay, there's another question here. What is the maximum context supported? Is it based on licensing, or is it based on the hardware spec? And it's actually based on both. So if we take a look at Cisco's website, let's go to cisco.com/go/ASA. And let's look at the data sheets here. And there should be, or actually compare models. So these are the two platforms that we're dealing with. ASA 5510 with the Security Plus license, and then also the ASA 5515X. So you'll see, of course, there's a difference in throughput. So the X is faster to do stateful inspection than the regular one. Same is true with like the number of connections, the VPN throughput. But then if we look at the, let's see here, there should be one of these that says, the number of contexts, we may have to look into the release notes of the individual boxes, but there is a difference. So for example, if we look at, let's look at one of the boxes here, this ASA 1, and if we show version, this is ASA 5510. So depending on the license, this one here has Security Plus. This supports up to 2 contexts. Then if we look at the X, here ASA 3, if we show version, this is 5515, which is the X version. And this one likewise supports 2. So it actually it's based on the hardware and on the licensing. But we'll talk about that when we get to the specific context section. And the reason that this is kind of important to talk about also, the number of contexts, is how this has to do with failover. And you'll see that that's one of the features that it talks about here in the data sheet. If we look at like the small and branch offices, some of these support only active standby failover, not active-active, which means that you have a pair of firewalls, and the question is, are both of them forwarding at the same time, or is only one of them forwarding at the same time? So you could think about this like kind of how HSRP works in iOS versus GLBP, where HSRP says that there's only one active forwarder, GLBP says that there's multiple ones at the same time. But this has to do with the context. So I'll find this section. Somebody mentioned here that it's under the licensing section in the documentation, but we'll come back to this when we actually get to the multiple context mode. So the answer is yes. It's both hardware dependent and licensing dependent. Okay, now there's one thing that is important to note here about the context and the firewall modes, that these are essentially mutually exclusive. So in single context mode, you could run as a routed firewall, but you could also run as a transparent firewall. Likewise, in multiple context mode, you could run as a routed firewall, or you could run as a transparent firewall. The key point about this in the 8.x code that we are running is that you cannot mix them. So you cannot have one multi-context mode context that is running in routed mode and then another one that is running in transparent mode. I believe in version 9 this is now supported, but in the particular code that we are dealing with, it is not. So we'll see that this is going to have a large impact in the design as to what particular features could be tested on that box. So in the lab exam, if they configure one of the ASAs as transparent, it means that it cannot terminate VPNs. If they configure it in multiple context mode, it means that it can't terminate VPNs, it cannot do routing, and there's a bunch of other features that are disabled when we make these changes either to the firewall mode or to the context mode. So remember, the key point here is that we're dealing with version 8, which does not support this. In version 9, it does, but until they update the blueprint, at least within our scope, we have to take this into account, that there are software limitations of how these features work together. Okay, of course, then the ASA can also do VPN termination. And now, as I mentioned before, it supports both IKE version 1 and IKE version 2 IPsec, and then also SSL VPNs. So when we get to, first we're going to look at this with iOS. We'll look at the LAN-to-LAN variations in iOS, then we'll look at the ASA LAN-to-LAN variations, then we'll look at iOS remote access, and then ASA remote access, because the logic of how these fit together is very similar between the two of them. There's just some minor changes in the syntax of one versus the other. But the IKE version 1 VPNs, those are the traditional ones. IKE version 2, this is what they call Flex VPN in iOS. So it's basically a change in the negotiation, but ultimately it does the same thing. It's just forming an IPsec tunnel. So with IPsec, we support ESP, and we also support ESP over UDP and TCP. So we'll see that this is going to be related to when we do our EasyVPN remote access. For SSL, we support this over TCP and over UDP, which is the difference between TLS and DTLS. So when we get to remote access VPN and AnyConnect for SSL, we'll talk about, when would you want to use TCP, when would you want to use UDP. Supports both of them. What is not supported, though, is authentication header, AH. So in iOS, you'll see that there's some other legacy mechanisms that are still there, like you can do manual crypto keys without having to do without having to do ISACAMP. ASA doesn't support this. Same is true with authentication header. It's assuming that if you're doing VPN, that you want to do encryption. So we're going to be using ESP, then ESP with something like triple DES or AES in order to actually do the encryption of the payload data. Now we'll see that there's also other limitations that ASA does not support that I don't have mentioned on this slide, like it doesn't support GRE tunnels, which then means it doesn't support DMVPN. It also does not support GetVPN, which is going to be for our group encryption. Mainly it's going to be just for LAN to LAN or for remote access. So LAN to LAN is going to be with IPsec, which is sometimes called site-to-site VPNs. We also have IPsec remote access, which is the EasyVPN client and server. And then SSL remote access, which is either the WebVPN clientless SSL or the AnyConnect SSL, which is like your regular VPN client that you install on your software endpoint. So as I mentioned, we're going to talk about this in two different pieces. The ASA section now, we're mainly focusing on the firewall filtering capabilities and then the hardware-specific things, like how does failover work, how do the firewall modes, the context modes, and then the combination of that and failover work, because it's not very self-explanatory if you were to just look at the documentation and then try to figure this out. So once we look at the firewall features, then as we move into VPN, we'll talk about iOS and then circle back around to the VPN features on ASA. Okay, there's a question here, will GetVPN be covered? Yes, it will. So we'll be doing LAN to LAN on iOS and ASA, remote access on iOS and ASA, SSL on iOS and ASA, and then both DMVPN and GetVPN on iOS, and then also FlexVPN, which is the Ike version 2, on both iOS and ASA as well. So VPN is a very, very large topic scope for the exam and also for this class as well. But we need to make sure that we understand how the ASA works from a filtering point of view first before we introduce any of the VPNs, because they are mutually exclusive. If your filtering is configured wrong, then your VPNs are not going to work. And the same is true with the iOS. So if you're running zone firewall and VPNs at the same time, you need to make sure that the zone firewall config allows the VPN features to work before you can turn the tunnel on.